It's worth having a look at how electric motors actually do work. Sometimes people write the actual symbol in this manner here, where the little dot in the centre represents the tiny little axle or spindle, and then they put an arrow on it to indicate that it's going to spin round. So I think that's been dropped from the actual symbol for a motor that people commonly use, but it's a very useful thing to remember. What about these two blocks here? Well, we'll explain their origin shortly. Right, let's have a look. First thing about motors is this. These little paper pins are made of steel. They're coated in sort of yellowy orange, goldy coloured brass, but they're made of steel. And if we just take the motor and hold it sideways like that and bring it up, I think that gives one of the secrets away straight away, doesn't it? So there's our little paper clip there, and it's become magnetized. So inside the motor we've got magnets. So our little paper clip becomes magnetized. So we know magnetism's got something to do with it, but a magnet can't just make something turn continuously on its own. We know that we've got to switch our circuit on. We've got to switch it on before the motor can spin. So it's really a combination of electricity and magnetism. So let's open one up and have a look. So there we go, look. So this is a different electric motor which I've taken apart, and that's just sort of a holder to keep the little axle in line. We'll take that out. Oh, it wants to pop back in itself. It's as if it springs back in. Well, that's the magnetism, and here are the magnets. So those are the magnets there, curved shaped magnet, one on one side, one on the other, and inside the casing those magnets would be fitted against the walls of the casing, a bit like a tin can, so they're magnetized to the walls of the can. So we can take them off. There's the two magnets there. So that's basically what's inside an electric motor. Now there is something else that I haven't, can't remember what I've done with it, to be honest, and that's the two sort of terminals that go in. And the idea is, look, if these were the wires that were leading to the motor, they touch onto the very back part there, one on either side. So what's happening is this very strange little set of coils of wire, so this is hundreds and hundreds and hundreds of little coils of wire, are attached to that metal part there. So when we put electricity in from two wires, the electricity travels in these coils of wire. Well, because those coils are right next to the magnets, they have a magnetic effect which pushes against the magnets themselves. So what's happening here is we're using electricity to make magnetism in this special set of coils, and then the magnets that are already there push against them. They pull as well, actually, push and pull alternately, and then it causes the whole thing to spin. So maybe one day I'll show you that working outside the case so you can see exactly how it goes. But electric motors work by a combination of electricity and magnetism, and it's as if electricity plus magnetism produces motion. And when you think of all the gadgets that move because of electric motors, and if you just think of how important electric motors are now because of electric cars, well, it's no wonder that these things, if there's an awful lot of time and energy and ideas time and design time spent perfecting electric motors and making the most powerful ones and making ones that use the least amount of electricity. So that's our little introduction to electric motors.